Hey y'all. So at the end of our last video, we were almost done with number 9. We started out by plugging in the horizontal distance of 240 feet and plugging in the initial velocity. And then we got to where we had sine theta times cosine theta is 4/15. Then we used this identity right here to get the sine theta cosine theta into just one trig function so that we can actually use our calculator to evaluate here. So then we switched sine theta cosine theta for sine of 2 theta divided by 2. And now we're going to multiply both sides by 2 so that these will cancel and we'll get sine of 2 theta is equal to 8/15. And now, if we take arc sine of both sides, inverse sine of both sides, the inverse sine undoes the sine. So over here we just get 2 theta equal to the inverse sine of 8/15. And then if we divide that whole thing, both sides, by 2, we get theta equals the inverse sine of 8/15 divided by 2. So now I'm going to punch that in my calculator. Alright, now remember, make sure you're in the right mode. The answers are in degrees, so I need to make sure I'm in degree mode. If you look up here, it says I'm in radian mode. So mode, switch it over to degrees. Now I'm in degrees, and I will do inverse sine of 8/15. Make sure you close the parentheses because that will finish the inverse sine function. Then divide that by 2. And you get 16.11 blah 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 blah, which is about 16.1 degrees. Cool, huh? Alright, solve this equation on the interval 0 to 2 pi. Well, cosine of 2x equals sine of x. What can I do? Here are the double angle formulas from the cheat sheet, because we got cosine of 2x here. So is one of these going to be helpful? If we change it into cosine squared, then we'll have cosine squared and sine. It'd be kind of nice if we could just get one trig function. And we can get one trig function if we change the cosine 2x into 1 minus 2 sine squared x. So here we go. Cosine of 2x is 1 minus 2 sine squared x, and that is equal to sine of x. Now, I got a sine squared and a sine, and this is in quadratic format. So I'm going to treat this like a quadratic equation, and I am going to solve and actually, you know what? I can do a substitution that will make my life just a little bit easier as I'm writing. I'm going to say, let's let y equal sine of x. Then this turns into 1 minus 2y squared equals y. That's going to be easier for me to write for a little while. I would like to get this quadratic into standard form, which means I want everything all on one side and then a 0 on the other side. And I kind of like having my squared term positive, so I'm going to add 2y squared to both sides, and then subtract 1 from both sides. so that on the left I have 0, and on the right I have 2y squared plus y minus 1. And now I'm going to solve this quadratic equation. And I'm going to do that by factoring. So let's see. 2 times negative 1 is negative 2. The b value is 1. So I need two numbers that multiply to negative 2 but add up to 1. I think 2 times negative 1 does the trick. 2 times negative 1 is negative 2, and then 2 minus 1 is 1. So I'm going to put a 2y in front of each one. And then that's an extra factor of 2 because this isn't my factor to answer because 2y times 2y is 4y squared. But lucky for me, the 2 divides out of here, and so I get y plus 1 times 2y minus 1. And I'll double check to make sure that I factored that right. Y times 2y is 2y squared. Y times negative 1 is negative y. 1 times 2y is 2y. If I add those together, I get a positive y. Bing! And then 1 times negative 1 is negative 1. Ding! So this is the correct factorization. Y plus 1 times 2y minus 1. And then, if these two multiply to be 0, then one of them has got to be 0. So the solutions are anytime that this factor is 0 and anytime this factor is 0. So y plus 1 equals 0 and 2y minus 1 equals 0. Subtract 1 from both sides here and I get y equals negative 1. Add 1 to both sides and I get 2y equals 1. Divide both sides by 2 and I get y equals 1/2. And now, am I done? No, because the question's not asking me about y, it's asking me about what x values make cosine of 2x equal to sine of x. And so what I need to do now is I need to put my sine x back in for y. So, for y equals negative 1, that means sine of x equals negative 1. I'm going to change colors. So sine of x equals negative 1, and then for y equals 1/2, we get sine of x equals 1/2. So when does sine equal negative 1? See, sine is the y value on our unit circle, so that's right down here. So there's only one angle that gives us a sine of negative 1. Well, only one angle on this interval, and that is 3 pi over 2. So x could be 3 pi over 2. What x value or what angle is going to give me a sine of 1/2? Sine, remember, is the y value, so we're going to be up 1/2. So we're right here and right here. And that's pi over 6 and 5 pi over 6. So if you go in order from littlest to smallest, it's pi over 6, then 5 pi over 6, then 3 pi over 2. And that is D. And now everybody's favorite, proving the identity. Alright, so look at where we're starting. We're starting with sine of 2x over sine of x minus cosine of 2x over cosine of x equals secant x. So I'm going to start with the left side. And then, as you might guess, I'm going to use I got sine of 2x and I got cosine of 2x. I'm going to use double angle formulas. So sine of 2x is going to become 2 times sine x cosine x. And make this come back. Cosine of 2x, I'm thinking since it's going to be over cosine x, I want to use one that has cosine in it and probably not have sine in it because that would make this a little tougher to simplify. So I'm probably going to be using the 2 cosine squared x minus 1. Alright, cool. Now I am going to, so now why was I allowed to do that? I used the double angle formulas for sine and cosine. Now I'm looking at this and I'm like, all right, what am I going to do now? Well, it looks to me, this is all multiplication on top, and then sine of x times 1 you can think of on the bottom. So these sine and x's will cancel out. So that is, so if these sine x's cancel out, then I have 2 times cosine x left right here, and then minus, and now you can split a fraction if there's a sum or difference in the numerator by putting them over the same denominator. Because if you think about what are the rules for subtracting fractions, it's you get the common denominator and then you do the top minus the top. So this right here would simplify to that, so that means I can break it apart as well. Now, why do I do that? Because look what's going to happen right here. Cosine squared over cosine, we're going to have some canceling there. So you're going to have to be using your math algebra skills here. So cosine squared over cosine, those will cancel. So I'm going to have 2 cosine of x minus 2 cosine of x minus 1 over cosine of x. Then I can distribute my negative through here. So that's going to be 2 cosine of x minus cosine of x plus 1 over cosine of x. 2 cosine of x minus 2 cosine of x is 0, so those will cancel out. So I'll be left with 1 over cosine of x. And what does 1 over cosine of x equal? Secant of x. That's just the definition of secant. Well, I suppose that this has probably been the funnest thing you've ever done. And you're welcome. Talk to you later.